Hello, everyone, and welcome to this Scale Computing Technical Roadmap session. Today, we are joined by Chris Neitzold, and we will be covering virtual desktop and server-based computing infrastructures. And in Chris's session, he will be focusing on the hardware platforms offered by Scale Computing. Chris, take it away.
So thank you, everybody. I'm going to be going over the more hardware aspects. If you do have any other questions, go ahead and pop them in, and I will address them as soon as I see them. All right, so you're probably aware of our product portfolio range from the HE150 all the way up to the HE5000 series. And I wanted to focus a little bit on the GPU-enabled systems, and then we'll also touch briefly on the NVMe-enabled system. So for the GPU-enabled systems, we have the HC1250 DFG. That one packs 2 GPUs per 1U node. We also have the 5250 DFG, which packs 5 GPUs per 2U nodes, so a bit higher density on the GPU side of things. The 1250 DFG, really, this product is positioned to provide GPU, but really do it with a leaning towards higher CPU density. So really, when you're looking for more CPU density, because it's not always the need that you'll need a massive amount of GPU. It could just be that you're enabling GPU specific applications or applications that'll benefit from GPU, but you don't necessarily have the heavy lift that might be needed from, say, a CAD workstation or even a scientific type workload. And this is ideal for that sort of situation. Whereas the 5250 DFG really focuses more on GPU density. And that can be a bit at a sacrifice of the CPU density, although we do have a full range of CPUs that can kind of fit just about any need. We start out with the 4215R. It's a higher core clock, 8-core, 16-thread CPU, and there's 2 of those in each of the nodes. And that scales all the way up to the 6230R, which has 26 cores per CPU, giving you a total of 104 threads per node. And just to give you an idea of what that looks like, we really are using just about every piece of the real estate within that 2U form factor. On the front of the system, we are limited to 8 drives so that we can optimize cooling for all of the GPUs that are packed inside. And so really to focus on the sizing aspect of it, the 1250 DFG, just having the 2 GPUs per node and being able to leverage a little bit more on the CPU end, that really does it addresses the need for higher CPU capability, whereas the 5250 DFG is going to give you a much broader density of the GPU. So as far as the GPU itself, we are looking at the NVIDIA T4. The T4, originally released as an inferencing accelerator, is also a very nice kind of middle-of-the-road Turing-based GPU. And it comes packed with 16 gigabytes of frame buffer. And so this allows us to build up to 16 individual GPU-enabled workstations per GPU. And so in a 1250 DFG with the 2 GPUs, that's 32 desktops per node. And with the 5250, that scales all the way up to 80. One of the other reasons that this one was chosen is for its low power consumption and also the low hardware complexity. We're not looking at any additional power inputs, no additional cabling. There's no active fans, so there's really very little from a hardware perspective that can go awry. And so you just have these kind of solid state GPUs that are sitting in there providing that functionality. And as far as the GPUs themselves and how they're used, with a single T4, it can be configured to be kind of your traditional GeForce desktop or consumer graphics card, a Quadro for more of the professional applications, along with the certified driver. Can also be configured to run applications or host applications, or even just create more of a Tesla-style GPU. And for each of those, we use profiles to define how those are defined within each GPU. Each physical GPU can contain a single profile, but you can run multiple profiles on a cluster by utilizing the individual GPUs. And this is done by applying a tag to the VM. The tag will define what type it is. So if we take, for example, a standard consumer GeForce GPU, that would be the B profile or the virtual PC. Within the virtual PC, if we wanted to apply a 1 GB frame buffer, so we could have 16 individual instances, then we would apply the scaled GPU T4 1B tag. And to answer a question really quick from Boris, are the NVIDIA GPU cards native NVIDIA cards, or do they have special scale firmware? No, they are native NVIDIA cards, so we're not adding any additional code in there. They're just using standard off the shelf. No problem. And so to address Andy's earlier question, is there a specific REST API to provision vGPUs? There isn't one specific to the vGPUs themselves. However, there's already functionality within the API that can be leveraged, and that would be the vir domain create, and you can specify the tag. And then going further, you could also leverage snapshot replication and then snapshot cloning to distribute that out. And Stefan brought up, do you need to purchase additional licenses from NVIDIA for the GPU sharing? The answer to that is yes. It uses the standard NVIDIA grid licensing scheme, and there's a variety of license types that can be chosen. We'll generally try to steer people towards either the VPC or VDWS, Digital Workstation, specifically because it enables, or Digital Workstation or VDWS specifically, because it enables all of the profile types. But if you only need standard, just simple VDI, VPC can be a more cost-effective means of doing that. All right. So with that licensing, there is a licensing server that has to run with just accessible to the cluster or accessible to the VM somewhere. And so to leverage William's previous illustration, that can be placed either as a VM within that secure infrastructure. You can also set up a secondary license server to make sure that you have redundancy in the case that one goes down or it becomes inaccessible for any reason. And those can also be placed outside, anywhere that they're accessible over the network. Any other questions on the GPU systems before we move on?
I think you got them all so far, Chris.
All right, fantastic. So with that, I did want to also touch on our HC3250DF. This is our first kind of NVMe first offering, specifically built for performance and really just kind of raising the bar on performance. So this system, it uses the same CPUs and the same general architecture as the 1250 DFG and the 5250 DFG, but with a focus on performance, and specifically storage performance, and then also just the general architecture performance. We've gone through and made sure that we have a full 4 lanes of PCI Express to each of the devices, that there's no sharing, no switching, no retiming, or anything in the way that would cause additional latency. Additionally, we paired this with the option of going to 25 gig networking. And so this gives us a little bit more speed on the backplane and also just for the network connection itself. And then also I wanted to call out that the 3250DF is a UEFI native design. So rather than going with the standard BIOS legacy architecture. This is UEFI from the inception on the host, which can also then enable UEFI within the guest. So the reason that we've chosen to go UEFI, obviously the entire industry is going that direction, but for us, what that brings is a simplified pre-boot process, higher resilience. And when I say higher resilience, I mean, if we lose a boot device or if we needed to remap a drive, that's much easier to do. We don't have to deal with, special boot sectors or imaging an MBR. We can just, it's simple file management. And then this also gives us the potential for extended TPM 2.0 support. And so with that, for the guest OS for VMs, we will have a dropdown where you can select the boot type on a per VM basis. We also support importing, say, a legacy VM and converting that over to UEFI, or it can remain on legacy. And those will be integrated in, I believe, 9.0. This can also then have the knock-on effect of enabling features like secure boot. All right, and with that, I just wanted to call out the new CPU selection. This has been applied to a whole range across our product portfolio. You'll see, of course, the previously mentioned 4215R, the 6226R, and the 6230R. And I really like to call out the 6226R as being kind of a special, really value within the Intel product stack. You're looking at a 16-core, 32-thread processor with the full gold bus support, the UPI speed, the memory speed, but still maintaining a very high clock speed. And with that, I'll open it up to any additional questions.